Okay. So third unit, digital electronics, C8392, synchronous sequential circuit. So for EC and mechatronics. So combinational circuits it consists of logic gates. The combinational circuits depends upon the present input. That is called as combinational circuit. Actually, we discussed about combinational circuit in previous videos. Combinational circuits. The example for combinational circuit is max demultiplexer, magnet comparator, encoder, decoder. So all the things are example for combinational circuit. Sequential circuit means we know that uh, sequential circuit it output depends upon the present input. Also, the output depends upon the previous outputs. So present input and previous outputs. It is called as sequential circuits. That means it contains some memory storage element. Okay, we can say that is delay part. That is sequential circuit. Difference between combinational and sequential circuit. So combinational circuits output depends only on present inputs. Sequential circuit output depends on both present input and present state. That means previous output. Combinational circuit has a feedback path. It's not having feedback path. Sequential circuit has the feedback path. Combinational circuit doesn't have the memory element. Sequential circuit has a memory element. And clock signal is not required for combinational circuit, and sequential circuit clock signal is required. And combinational circuit is easy to design. Sequential circuit is difficult to design. Types of sequential circuits. There are two types of sequential circuit. One is asynchronous sequential circuit. Another one is synchronous sequential circuit. So asynchronous sequential circuit means there's a clock given to the first device, and second and third devices the clock get it from the previous devices output. So that is the first device getting induced, and then the output is come from the first device. Then only second device get it introduced. So the way how they will be in work, it can't work all the device simultaneously. So this is asynchronous sequential circuit. Synchronous sequential circuit means the clock connected all the devices. So at the time every device was getting triggered or induced by the particular clock signal, that is called a synchronous sequential circuit. So this is so about clock signal and okay. So clock signal and triggering, that we will discuss now. So clock signal, it's periodic signal. We know that it's on time, off time. It needed to be the same. So its signals are in square wave, both on and off time. It's the same. See, so this is on time, and this one is off time. So this total time period, total on and off time. Okay, actually this is on means this is off. So this on and off total period we can say that time period of the clock. Okay, and also that another type of the clock is train pulses. So when on time, off times are not same. So that is also here. See, on time is maximum period, off time is minimum period. So this is like train of pulses. And types of triggering, how the circuits or devices getting triggered by the clock. So there are two possible types are used in sequential circuit. One is level triggering, another one is edge triggering. So what is level triggering? So there are two types, two levels, namely logical high and logical low. Okay. So positive level triggering and negative level triggering. So positive level triggering, the positive places, the shadowed places. So this as positive level triggering. The logic high, it is highlighted below the figure. That dark shaded place. And negative level triggering. Negative level means this is the places negative level triggering. So where whenever the negative edge will come, the device getting triggered. That is called as negative level triggering. Okay. So maximum this latch circuits are triggered by level triggering. So positive and negative level triggering. Then edge triggering. So edge triggering also they have classified into two. One is positive edge triggering, another one is negative edge triggering. So positive edge triggering means so this is positive edge triggering. That means during the transition time, uh, uh, the the transition period, it is 0 and it is 1. So the transmit the trigger that during the transmission time means it is converting 0 to 1, that low level to high level. So it's of rising edge. Okay. So that is for positive edge triggering. The another name is rising edge triggering. Okay. So negative edge triggering. Negative edge triggering means so during high to low transition. So high means 1, low means 0. So 1 to 0 transition, it is negative edge triggering. The another name is falling edge triggering. Okay. Okay. So these are the triggering in the sequential circuit. So remaining thing we will see in next classes. Thank you.